So let's go look at glycolysis. Glycolysis, first of all, just means glyco is glucose or sweet sugar, and then lysis means breaking something apart. So we're going to be breaking sugar in this. We're starting off with glucose 6-phosphate, and then we're going to change that into fructose 1,6-bisphosphate. Wait a minute, we gained a phosphate. How did we do that? Well, we actually use this thing called a kinase. In this case, it was phosphofructokinase. Now, a kinase is a type of enzyme that transfers phosphates. So in this case, it took 2 ATP and took their phosphates, one from each, and made transformed that into 2 ADPs. And then it took those phosphates and added them to the sugar over here to make fructose 1,6-bisphosphate. This fructose is now going to be broken up into 2 3-carbon molecules, and then each one of those will undergo a bunch of other enzyme catalyzed reactions. And then throughout that, there's going to be NAD+, which is going to be reduced into NADH, and then there's also going to be 2 ADPs phosphorylated to become ATP. Wait a minute, what kind of phosphorylation is this? Well, it's substrate level phosphorylation with an enzyme bringing together a phosphate from this molecule eventually after all these reactions, and then an ADP combines them, and voila, you get ATP. Now this is going to happen to ATP over here, to ATP over here, so you get a net of 4 ATP. A total of 4 ATP. But remember that you invested 2 ATP in the beginning to make this glucose more reactive so that we can break it apart later on. So you get a net 2 ATP from glycolysis. And what happens after this? The pyruvate is either going to stay in the cytosol and continue with fermentation in anaerobic respiration, but if this organism does aerobic respiration and they have mitochondria, then this pyruvate will undergo some modifications, which we'll talk about next, and then it'll go into the mitochondria for the Krebs cycle.